Hi, my name is Freire and I'm here on the behalf of my team. We developed a study that used Now Robot as a tool operator in therapy sessions with mentally impaired individuals. So, first I will make a contextualization of the subject followed by a presentation of the objectives and methods used for the study, including a brief introduction of the materials and experimental design. Then I will focus on the results obtained and I will make some conclusions about the work. Furthermore, I will also talk about some problems and limitations that we have found. In the last decades, a new generation of robots has emerged, the social assistive robots, which have been used to aid human beings in several tasks, and the mental health care sector is no exception. Recently, several studies were made using Now Robot in cognitive therapy sessions regarding the elderly population and children or young adults with mental disorders, in order to either prevent cognitive decline, improve psychosocial outcomes, or the patient capabilities and lifetime. Individuals with mental impairments are often characterized by not being able of living by themselves and independently, due to delays in their development of social, cognitive, and motor skills. Further, they often exhibit attention deficits and are stubborn by nature. For those reasons, mentally impaired individuals live often with care providers or in specialized group homes. However, even when inserted in these specialized group homes, mentally impaired individuals often show resistant behavior and tantrums whenever they don't want to do a specific task. Therefore, the aim of this work is not only to understand how the human-robot interaction process actually occurs with people with cognitive impairments, but also to test the application of the humanoid robot now in the therapy sessions of the study group and verify if this kind of human-robot interaction really impacts the improvement of their cognitive skills and development of eye gaze and joint attention. The robot adopted in the study was now due to its simplified and accessible human-like features. Now is in its 6th generation and has 58 centimeters in height and weighs about 4 kilograms. Now also has 25 degrees of freedom, 9 tactile sensors, 2 2D cameras, 4 directional microphones, 2 sonars, a Bluetooth Ethernet Wi-Fi connection, motors, is running on a built-in Linux-based operating system, and has a lithium battery. Therefore, now is not only extremely interesting due to its physical features, but also due to its components that allows it to dynamically interact with users and the surroundings. Now can be programmed through several ways, though for this study we used its multi-task application, Choreograph. The intervention involved 12 participants that were submitted in groups of 3 to 2 different approaches, a robot-based approach and a game-based approach. Both approaches were video recorded in order to allow the analysis of the participants' behavior afterwards. As mentioned, in the robot-based approach it was used the humanoid Now and its multi-task application, Choreograph, with a Wizard of Oz approach. On the other hand, for the game-based approach, we used a PowerPoint presentation with a 2-level game. Furthermore, in both approaches, the objective was to tell which color was either Now's eye color or the drawing in the slide respectively. Therefore, the study involved several phases. It first starts with a general introduction, where the operator introduces herself to the group and briefly points out what is going to happen. Afterwards, the robot-based approach starts, with the operator introducing Now as a robot, and soon after Now starts the introduction and the game. A Wizard of Oz approach was used instead of the models offered for communicative dialogue in Choreograph, once that Now needs to be instructed to search for sounds at specific moments, in order to allow its built-in algorithm to translate the sound into an answer recognizable to the robot. Thus, once that the objective was to work with mentally impaired individuals that often show dictation issues as well as introvert personalities, it could lead to errors in the detection of the words. Therefore, a Wizard of Oz approach was safer to use once that the operator is the one controlling Now's interaction at all times. After the group finished the robot-based approach, the operator does the transition to the game-based approach, starting by explaining the computer game to the group. Then the operator conducts the game, asking questions and helping manipulating the computer. In Figure 2, it's possible to see the simplicity of the experimental setup that consists in just one area of interaction with both the robot and the computer at high height of the participants. Furthermore, in Figure 3, it's possible to understand how now's eye color works in between colors. Figure 4 is a representation of the first level of the game-based approach. In order to better understand the results, it's important to understand that there was the need to create categories in order to count the amount of times that the individual looked away. In the game-based approach, we have the total and the self-distracted categories. The total stands for the total amount of times that the participant looked away, and the self-distracted category takes in account the amount of times that the participant looked away for no reason. On the other hand, in the robot-based approach, in addition to those categories already mentioned, we create another one, the no interaction, that counts the amount of times that the participant looked away when there was no interaction from the robot during the approach. Through the graphs, it is possible to observe that 7 out of 12 participants looked away more often in total during the game-based approach when compared to the robot-based approach. Moreover, if we compare the number of times that the individual is self-distracted in the game-based approach with the number of times that the individual was distracted during the now's intervention, which means that we have to subtract the no interaction to the total, it's possible to verify that 10 out of 12 of the participants were more focused on the robot-based approach. Once that just individuals B1 and C1 either kept the focus on both activities or were more distracted, respectively. It was also interesting to understand that in the group B, even though the participants spent twice the time in the robot-based approach, they either kept their focus in both approaches or were more focused in the robot-based approach. Hence, several were the participants that treated now as a social being, either by trying to talk to it or physically interact with the robot. With this study, it was possible to conclude that the results from both sessions with the mentally impaired young adults were actually positive, once that it was possible to assess the efficiency of now as a teaching tool that is able to capture the group's members' attention, once that during the robot-based approach was notorious an increase in joint attention and eye gaze of the participants. Moreover, it was also verified that the interaction of the study group does in fact change in the presence of the humanoid, paying in overall more attention during Snow's approach than during the computer game 1. Therefore, Now was capable of improving the group's resistance behavior and their attention. Thus, we can consider that Now is a considerable efficient tool that should be applied in institutions like this one. Although this study has presented itself as an overall success, there were some drawbacks during sessions that should be considered in future work. There were internet connection problems which interfered with the loading of the commands to Now, which create a void where there were no interaction from the robot with the participants. It was also detected some instability in the intensity and duration of the Now's eyelids. Moreover, this study did not allow to test the viability of Now in a long-term application. Therefore, a more autonomous approach should be preferred in future approaches. Thanks for your attention.